Problem 5. Now we're graphing the secant function, and just to remind you, secant function is a reciprocal function for cosine. So I might remind myself that I could graph cosine of 2x first. In fact, that's probably the best thing to do. If you graph that first, then you can graph secant after that. So cosine of 2x, on this one, keep in mind what the period is. Will equal pi. So we'll have one complete cosine cycle in pi. So starting at 1, I'm going to want to, at pi fourths, cross through 0. At pi halves, bottom out at -1, back up through 0 at 3 pi fourths, and at pi, end up at 1 again. There's one cosine cycle, but we again like to graph through 2 pi. So let's go ahead and repeat that. So we'll have 2 cosine cycles in 2 pi. Now, because they're reciprocal functions, secant and cosine, whenever cosine graph crosses the 0, the reciprocal for 0 is undefined. So that's where we will find those asymptotes. And go ahead and draw those in. Everywhere cosine crosses the x-axis creates an asymptote. And then once we've got that, the secant graph is fairly easy to draw. Just make those little U-shaped fellows along the asymptotes. There we go. There's the picture of secant. So we don't usually talk about amplitude with the secant and the cosecant graphs, but period is going to be how long does it take to make one full cycle. And I think you'll find it matches the same as cosine. It took pi for cosine, so for secant, it takes pi. Horizontal shift is none. Vertical shift is none. Range, negative infinity up to -1, including -1, and then join that with including 1 to infinity. List the asymptotes. Just by looking at the graph, you can see the first asymptote's at pi fourths. The next asymptote is at 3 pi fourths. And the one after that is going to be 5 pi fourths and 7 pi fourths. And again, by looking at the graph, where does the secant function here that we've got drawn cross the x-axis? It never does. So there are no zeros. And that problem is finished.